This is an example from 5.3, and we're going to get into just a couple examples of proofs using the sum and difference formulas. So here's a proof that we'd like to do. Now, like any proof, what you want to do is you want to pick a side and then go from there to try to identify the other side, to try to prove the other side. So we're going to start here with the one that could use most easily one of these sum and difference formulas from down here. That tells me I want to start with the left-hand side. So I want to start with sine of x minus pi over 2, because that one can easily be plugged into one of these 6 sum or difference formulas. So like last time, I'll number them as 1, 2, 3, 4, 5, 6. And we're going to decide which ones they are. Now obviously we're not talking about tangent. This is a sine one, so we're either using 1 or 2. Since we have a minus in the middle, looks like we're using number 2. So this is our identity for this particular case. All right, so we're going to just, plug it in. We're going to use this as u, and we're going to use this as v, and see what happens with this whole thing. So we're going to expand it out and then see what we can do with it. Hopefully, eventually it goes down to negative cosine. All right, so sine of u, cosine of v. So sine of x, and then cosine of pi over 2. We're going to use the positive version because the minus is taken care of in this part right here. But then it's minus in the middle, and then cosine of x, sine of pi over 2. So we've got it all written out, and now we need to see what we can do to simplify. Now, one thing I would like to turn your attention to here is notice that cosine of pi over 2 and sine of pi over 2, both of those can be evaluated. Those are quadrantal angles, and so I'm just going to do maybe a little side note up here. Pi over 2, remember, is this, and it occurs at the point 0, negative 1. So if we're doing cosine of pi over 2, well, cosine is the x value, so that means that cosine here is actually the same thing as 0. Sine of pi over 2, whoops, I don't know why I put a negative there, it's positive. Sine of pi over 2 is the y value, so that's just 1. So that's going to be a 1 for the sine of pi over 2 and the cosine of pi over 2. That takes care of a lot of the junk that we have in this problem. We're going to, get rid of those now. So it's sine times 0. The next step, sine of x times 0 minus cosine of x times 1. Well, anything times 0 is just 0. Anything times 1 is itself. So now we're able to jump to the last step of this problem and say that it's just negative cosine x, and that is what we were trying to prove. That is the right-hand side, and so now we're done with this proof.